But yeah, if you get into LaTeX, you're going to have to worry about embedding those figures within floats and things like that. Yeah, so the other example I thought was just to highlight a few other features. I've been learning a bit of Bayesian statistics lately, so I thought, oh, well, this is a really cool way to do your math homework, you know? Try and record what you're doing, and you know, you're reading an idea, you can do a little simulation quickly, you can write your equations down, you can do all that sort of stuff, and it's quite nice. So, you know, this was just me doing a simple example. Well, actually, I found it very complicated, but yeah, I got there in the end. And you know, it's just sort of an example of where you can simulate some data and produce a plot, or you can throw in your LaTeX equations if you want. You can output some, you know, results of the simulation, produce plots. Yeah, I don't know if anyone wants me to actually go into this example too much, but probably just interests me. This was another example that highlights the use of caching. So, not a very good example because I think so that's how long it took to run like that. Might have been quicker. I don't know. But basically, if you had some analysis that took a long time, then this command here will make things go a lot more quickly. And you'll see here, all the figures are saved automatically into the figure folder. And this cache folder stores all the cached analyses. So if you ever get caught up with dodgy cache, then you can just delete the contents of this folder and things will be back to normal. But in general, yeah, if you have, I find if analysis is going much more than 10, 20 seconds, I'll want to add this line of code here.
And do you have to explicitly run that again with cache turned off, or does it detect whether the chunks have changed? Or? Yeah,
it's pretty good. So if you change one letter or one spacing thing in a code chunk, it will realize that that chunk needs to be rerun. The main issues you might get is if you have certain dependencies between code chunks. So there are ways of doing that as well. So you can say this chunk depends on that chunk and things like that. But yeah, most of the time it seems to work pretty well by default. And if I get a problem, then yeah, I'll just generally I don't have analyses that take years to run. It's more like, oh, it takes a minute to run. So I don't really mind if every now and then I have to clear the cache.
So do you demarcate a portion of the code to cache? So say it was your data preparation or whatever?
You can, yeah, this is a global option, like cache equals true, but you can write, you know, something in here like cache equals true, and it will just cache that chunk. But generally I just if I need it, I'll cache the whole lot, and if I have troubles, I'll clear the cache. So I guess if I don't need it, then I probably won't turn it on, because it does introduce a couple of potential issues if your code gets out of cache, and sometimes it can make it just a little bit more tricky to debug something because you didn't realize it was a caching issue. But in general, I find it works surprisingly well.
I might be anticipating where you're going, but you've got the R Markdown is being converted to HTML.
Yep.
In the example there. If I now did say, all right, I'd like to put that into a PDF, can I just run some other option from knitr and it'll spit it out and make some assumptions about page layout, or is it a much more complex kind of?
Well, there's a few options. I mean, I can open this in a browser and go, you know, Control P, and go, I don't know, save as PDF. And
okay, so that's the browser, isn't it, doing that?
Yeah, I'll talk about Pandoc at a little point where there are various. I've looked into a couple of command line options for doing it. Yeah. So Pandoc gives you a lot of power. Yeah. Okay. But that's especially if you want to automate it in some way. So I should also mention, excuse me, this is an example of an inline R code chunk. I'm not sure if anyone's used SWeave where you have the, I don't know if it's called Sexpra or SXpra. It's capital S, E, X, P, R, and then braces. It's a way of including R code inline. So if you, I've got a couple, maybe I'll show it with this example. So I ran this initial thing which imports my data. This was it was Olympic medal data from the first Olympics to 2006, I think. And so, you know, you've got this.
Wrong directory.
Oh yes, I have to set as working directory. Oops. So tiny. So one other thing is it makes it very easy to change your working directory. So this is just some Olympic medal data. One row is a medal. It's got gender and medal and things like that. And so I can use, I can incorporate inline R code as well. So if I'm actually writing a sentence, so the Olympic medals data frame includes X medals. Well, instead of like reading the table and writing it in manually, and then what if the data changes? Then I'll have to go through all my text to make sure all the text changes. I can include R code inline. And so the R code here is n row medals, which tells me the number of rows in that data frame. And it's delimited by backtick R space, then all your R code, and then backtick. So we can see here in this text, it says the Olympic medals data frame includes 2,311 medals. From, and then I've taken the minimum of the year, 924, to the max of the year, 2006, and that's when you compile it, displayed in the text. So to make sure that you don't do copy and paste errors and that kind of thing. So that sort of also explains a little bit why this is formatted the way it is. So this first bit, backtick R, is saying that it's an inline code chunk. And generally, yeah, if you want to have some global settings for knitr, you put it right at the start of the document. And this is just sort of R code for knitr. They use this relatively new convention of sort of using dollar methods anyway. And all your global options would go in here, comma delimited. So cache equals true, or you want to have a particular figure size or figure width, or
it looks like you don't need crazy escaping when you use dollars in those expressions.
No.
With SWeave, it's a bit have to look up the documentation every time.
Yes, I think I know what you mean. So yeah, you can. I think it's really nice to be able to incorporate inline code, and then you can include a formula. One thing is a variant on inline code is sometimes you want to surround it by capital I, because by default it will display things as sort of this sort of typewriter font. So if you don't want the typewriter font because you want to incorporate it in a literal way, then you surround your inline code chunk with a capital I. So that allows you to sort of write an equation, for example, with the actual numbers in there. Yeah, so anyway, lots of examples here. I don't know if anyone wants to. Maybe I'll just show one example of a table. This is quite cool also. You can click here and you can, if you've given your chunks names, you can go to that chunk quite easily. So I should mention you can run chunks and run individual chunks and run all chunks and so on. So let's have a look at what if you want to produce a HTML table? I think that's one sort of extension that you might want to be able to do, to be able to output a HTML table, because you're not happy with basic output. And for that, I've typically used what's called xtable. So there's a library xtable and there's a function xtable. And xtable can output HTML or LaTeX tables. There's heaps of options, massive numbers of options for LaTeX tables, and a few options for HTML tables. And so, I don't know if we can see here, but that by default, it takes a, what is it, data frame, I think. And then you can add a caption and say how many digits you want numbers to be displayed to. And then you apply the print method to xtable, and you can say, I want it to be of type HTML. You can tell you where you want the caption, whether you want these row names, which mean absolutely nothing displayed, no. And I think you give an alignment and stuff. So if we run that, we'll see what we get is, for those of you who know HTML, you'll see something familiar. You'll see table tag as and a closing table tag, and then table heading tags and table row tags and table cell tags, and with the detail in between. So it'd be a pain to have to write that manually, so this saves you the time. And if you use results equals as is, then that text just gets plonked into your Markdown file. And as I said before, Markdown will just pass HTML right through, and so it'll come out as a HTML table, whichever one. Here it is here. Its exact formatting will depend on your style sheet, which is in your header. But it's probably good enough for basic purposes. Yeah. So do people have any questions about? Okay.
Can I ask a silly question? If you didn't want to include the code?
If you don't want to include the code,
yeah.
Echo equals false. If that's what you mean, the input code, yeah. So you just have an option, echo equals false, and it wouldn't show that. So, yeah, these are just some of the main code chunk options that I often end up using. One is to put a global option for cache equals true at the top. In terms of specific local code chunk options, yeah, I often use echo equals false if you just don't want to show the input because you just want to show the output to someone or yourself. There's also a bunch of other things that sometimes pop up, like warnings, errors, and messages, which can also be not what you want if you just want to keep a clean document. Of course, you should listen to warnings and errors, but if you don't want them to display, you can put these options either in the global options or in the local options. If you just want to have some preliminary code that you don't, that produces some output, but you don't want to show it, it's just doing a bunch of things and you don't want to display any output, you just want to run the code, then you can hide the output, results equals hide. If you are displaying console input, UE designed a feature where it tidies up your R code to make it arranged nicely with proper spacing and all sorts of things, but sometimes I put effort into making my code look pretty anyway, the way that human perceptions of tidy is generally better than any algorithm, so if you want to disable that or it's doing weird things, you can. And as I say, the as-is option for the results is quite useful if you want to output HTML tables or do a number of other sort of outputting of raw Markdown.
Can you stick some global parameters into the Markdown file? So, for example, if I wanted to put that results equals hide into every block of my code, but rather than have the hide be reproduced as a text string. For example, if I was doing some debugging, so I want to set top set debug to 1 and then have all of those marked.
That's a good. I should mention, there's an advantage of one innovation in knitr is that this can be a variable, or it can be a long R expression that evaluates to false or true. or it can be an argument, I guess. So, you can, if you had some variable that stored true false, you could put that variable name and it would run like that, I guess, yeah.
That would be setting it in the actual Markdown file, though, presumably.
Probably.
To parse that.
You could use getOps, surely, at the top if you wanted to pass it in.
Okay.
Yeah, I mean, one option is just to write results equals height, like comma results equals height here, and it'll apply to everything.
All of them, that's true.
Or you could you could have some variable with a script or something, I guess. I've already mentioned this, but yeah, the two kind of options for inline code, you've got this one which produces backticks Markdown and surrounds it with code HTML, which may be what you want. You're incorporating some inline results and you want it to be clearly displayed. But if you just want raw results, then you surround it with this capital I business. As I said, you can incorporate multiple figures, and it can be interspersed with console input and output. There's lots of options. You just go to the website, you'll see some of these options, width and height, and you can use different devices, PDF, PNG, and there's a bunch of others I haven't looked into. Also, there's just default R stuff if you want to have multiple graphs in a plot. So, for example, you can use the graphics setting with base graphics. This one, for example, will allow you to arrange plots in a 2x2 grid, or that could be 3x3 or 4x4, whatever you put these numbers are. This creates a matrix of base R plots. Or if you're into ggplot, you could use something like the grid arrange function, which allows you to have multiple ggplot graphs in one spot. As I mentioned, I'd probably, if you're wanting to do HTML tables, Xtable seems like the way to go. If you're really keen, you can output raw stuff yourself, write custom code, or you could use the GitHub extensions. But yeah, for basic reports, I think Xtable is probably enough. And if you really want fancy tables with line breaks, I think LaTeX is probably a better option. Unless you're a wizard with CSS style sheets, which I'm not yet, but maybe others are. Yeah, so that's just an example I showed before of what an Xtable example is. As I said before, caching is really good if you've got long analyses. And yeah, that's just my decision rules, which I think I've already mentioned. If it's reasonably quick, don't worry about it. If it starts getting a bit slow and it's annoying you, chuck in global cache. Causes problems, delete cache. And if you've got really slow analyses that take a long time, then you might want to get more serious about defining your dependencies so that it updates properly when you change code and so on. Getting to the idea of how you create different types of documents or how you control the output, there's a new package that was just developed called Markdown. So it's an R package called Markdown, and you see the people who've developed it. Jeffrey Horner's posted about it recently on his blog. And it basically gives you more options in how you convert Markdown to HTML. So if once you really start getting into this, you might want to start thinking about, well, what do I want my HTML file to be like? I like to incorporate the output of a Markdown document as a code fragment with no HTML header no HTML header, so I can incorporate it straight into a blog post. So with this program, you can easily do that without having to manually extract certain bits. So you can also disable some of the default options. So for example, hard wrap, every time you press enter in the default format, and you go to a new line, it will present that as a new line. But if you're used to LaTeX where a single new line doesn't mean anything, and it's only 2 new lines that represents a new paragraph, then you'll probably find hard wrap annoying. So you can disable hard wrap. Or for example, I was often writing a list A in brackets, B in brackets, C in brackets, and by default, C in brackets gets turned into copyright, which is cool, but I was annoying. So that's what Smarty Pants is. If you don't like Smarty Pants, you can turn it off. Another thing worth remembering is base 64 images. So when it generates the HTML file, it generates the images kind of in the HTML document. It has this long string of text data that represents the data in the image, and that's actually in the HTML file. So that works pretty well in most browsers, but occasionally you get into trouble. So sometimes when you're trying to convert your HTML document to another format, base 64 images doesn't work, and you just want to have it referencing a figure in a folder rather than using this sort of self-contained HTML document style. So if you want to disable that, you can. So in short, if you're trying to produce your own workflows without relying on RStudio, then you can use some commands a bit like this. You can basically load the knitr package, load the Markdown package. This will knit the document. This is knitr function knit, which turns R Markdown into a Markdown file. You can then, this is a Markdown function, convert it to HTML, and dare I say, you could even open it in a browser. And as I say, if you just want to only show, only want to output a fragment, or you want to specify some other options, then you can use this Markdown to HTML options argument to change the exact display. Finally, if you want to get really excited and you're trying to convert from, I don't know, Markdown to PDF, or you want to produce a slideshow, or you want to convert to a Word document, or any number of other conversion tasks, there's an open source command line program called Pandoc, and I wouldn't say I'm very good at using it yet, but I hope to be one day. And yeah, it has heaps of options for converting between formats. And sometimes you've just got to be a bit conscious about how you set up your document and thinking about what that next format will want. But if you're into it and you have some large production tasks you want to do, or you really want to have a particular output format, or you're just into the command line, then this has a lot of power for conversion tasks. For the PDF stuff, you probably need a LaTeX distribution. I mentioned also that when I define reproducible analysis, I think it's best if it's a one-click build. And by that I mean, well, in RStudio you can just click knit to HTML and that does the job. But for more complex tasks, you might want to explore things like a make file where you have a series of commands that are issued, or you might want to combine a set of commands with Pandoc, or specifying particular knitr options or Markdown options. So there's a lot of control if you want to get into it, but I think for basic analyses you can go a long way with what's provided by RStudio. But if you want to really customize it for some important task, then that power is there.
Do you think maybe that goes beyond just to customize it, but to be truly reproducible? Getting into a GUI and clicking something, whereas with make or something you can delete the cache or do all that kind of stuff. So I see another use case where you just want to make sure you reproduce it and it is the same every time.
Yeah.
There may be some stuff hanging around on the file, system, and you want to.
You've got a bit more options with, say, a make file or something like that. Yeah. It's also nice, I guess, it's sort of a little bit more platform neutral than, oh, you have to use RStudio to make this run or something. I'm not sure if time is permitting, actually. Do you want to see a quick example of LaTeX, or is it probably good?
I'll show us the page.
Yeah, I'll just show the page and then see how we go. This is just, I was trying to think of what I've got. So this is, unfortunately I can't share this yet because it's sort of a journal article I'm working on. as we speak, and I'd probably like to. But I hope to share it once it's published. So somewhere here is a file, an RNW file. So RNW, that's the old, it stands for R no web, and this is basically a LaTeX document where you have document class commands. It tells it it's an APA 6 because that's the journal format I'm going for, and a bunch of preamble statements for various options. Instead of backtick R, it's \sexpra. Instead of triple backtick R, it's less than, and then a greater than equals, and an asterisk to end. And yeah, other than that, it's pretty similar, except for the markup being LaTeX. And instead of knit to HTML, you've got compile PDF, which I don't know. So you can output something more like a document.
And did you do the presentation in Beamer, did you?
Yeah, actually, I used Pandoc and Markdown to combine. Yeah, which is fun. A little bit of fiddling, but that was all right. Anyway, I don't know if is that enough of a flavour of LaTeX, or you want maybe yeah. Do you have any questions? So yeah, final thoughts. I think R Markdown is awesome for people getting started with reproducible analysis. It's quick, you can show it to people, you can use it for your homework, great teaching resources, blog posts very simply. It's scoped for greater complexity with tools like Pandoc and controlling the options if you want. But at a certain point, I think things get sufficiently complex. You've got cross-references, you've got citations, then you probably want to slip into something like LaTeX, or I don't know, perhaps you've got completely different needs. And none of this meets your requirements, but certainly for the kind of stuff I do, quick analyses, I could see myself using it for a consulting report here or there, sharing with colleagues, and I think it's really good. In terms of where to find out more, the knitr website has a huge number of examples and resources. RStudio's there. If you want to learn about R Markdown, RStudio's there. I have a few posts on reproducible research, and if you have questions about this sort of stuff, R on Stack Overflow is really good. If you're interested in LaTeX, then Tech Stack Exchange is really good, and UE Share is really responsive in terms of handling questions and issues you might have about using knitr. So there's the GitHub repository where you can post issues, questions, or problems, and so on. So yeah, that's my talk on R Markdown. Yeah. So. Yeah, so as I say, people are welcome to hang around afterwards, both if you want to go grab a bite to eat, but also if anyone has any questions, I'm happy to